Now for the difficult bit. I've explained that we need the highest common factor. It's just mathematical knowledge to know that to reduce a fraction to its lowest form, you just divide the numerator and denominator by the highest common factor. The problem is finding the highest common factor. Now there is a little routine, you can just look it up on the internet. There's plenty. It's called Euclid's algorithm if you need to look for it, and we can write that quite simply in Java. We're going to call it HCF. So if I have a public function method which returns an integer, and if I call it HCF, I can send in the two values that I want to check, A and B. Oops. And I can return the highest common factor of A or B. Now this is not just a straightforward return. As I said, this is Euclid's algorithm, and the method that we're using here is called recursion. I'll do it first and show you what the code is, and then I will try to explain it in another video. So the code that we require is if A mod B is equal to 0, then return B. Whoops. Else, so if it isn't 0, the result of finding the absolute value. If it isn't, then what we need to do is recursively call the HCF function, but we need to swap around our A and B's, and in fact we return the highest common factor of B and the modulus of A and B. Now that will find the highest common factor of two numbers, which is okay to use it in point because we can always find out what the highest factor of two coordinates are, x and y. It doesn't really matter, it might be a redundant function. In fractions it's really important, but I've included it in point because it can also be used in point, and in fractions I would rather call this the lowest form. So we'll deal with that a little later on. So let's see if I can explain what is happening here. So